We are now continuing our discussion on geometric construction techniques for triangles. The first technique is a fairly easy one, drawing an equilateral triangle. So in this example, we are given a shorter length of a line. So the idea is we are going to draw an equilateral triangle with the length of a side equal to that shorter line. Okay. We only need to use our compass in this technique. So what we're going to do is copy the length of the side and transfer it on the horizontal line. We can mark the vertices or the endpoints as A and B. Next, we strike an arc using the length of the side as the radius of the compass and repeat the same step on the other point. So we now have 3 points which we can connect. So we first mark the intersection as point 1 and we can connect that to point A and point B, and so we have an equilateral triangle. So this is fairly easy to use, especially if you're constructing other types of triangle, like for example an isosceles triangle, and you are given the information on the two different lengths of the sides. Or you can also have an irregular triangle with all the sides given. Okay, but how are we going to draw a right triangle with some restrictions on the measure of one angle? So that's the next technique that we are going to discuss. Drawing a right triangle given the hypotenuse and a leg. So before we begin with the drawing, let us recall some concepts from geometry. Which of the following triangles have the largest measure for angle BAC? Line BC is the diameter of the circle in these illustrations. So, is it the left one, the middle one, or the right one? If you chose one of these figures, then you are wrong, okay? Because none of the triangles have the largest measure for angle BAC. All of them are right triangles. So we have a property in geometry or rather a theorem in geometry, which states that if a triangle is inscribed in a semicircle and one side of the triangle is the diameter, then the triangle is a right triangle. Okay. Now we are going to use this knowledge in order to draw a right triangle. So we have here AB as the hypotenuse, okay, and BC as one of the legs. Okay. So, knowing that the hypotenuse is the diameter of a semicircle, okay, we can draw a semicircle by bisecting line AB. So we have the center known, and we can strike an arc to form our semicircle. Next, we get the length of BC and strike an arc from either ends of A, or rather from point B. Okay, so strike an arc to intersect with the semicircle, and you now have the location of point C. Okay, so you just connect the vertices, and you will now form the right triangle with hypotenuse AB and one of the legs BC. Now for the third technique, we have inscribing an equilateral triangle in a circle. So we are going to apply the previous technique later on to demonstrate how this construction works. Okay, so given a circle O with the center marked as shown. Okay. So for this problem, we can proceed with the first step. But if you are given a circle or an arc with no center, it is important that you first find it because it will be useful with other constructions like constructing a diameter or constructing a radius uh, in that sense. No? Now, designate any point A in the circumference of the circle with point B located at the opposite end of the diameter line. So basically what we have to do here is to draw a diameter on the circle. As simple as that. Now, using point A as the center and radius r equal to the radius of the circle, draw an arc cutting the circumference of the circle at point B and at point C. So what you will have is a figure that looks like this. We connect D, C, and B to form an equilateral triangle inside the circle. So let's explain how did this or how is this valid in order to draw an equilateral triangle inside the circle. So remember that if we have a semicircle, okay, we have a right triangle with the hypotenuse on the diameter. Okay. So when we first made this arc, okay, arc BC, we have the length of BDA. Let's assume that this is equal to small b. Okay, the length of BA would now be equal to 1/2 of B. Okay, so knowing that we have a right triangle in the semicircle, we have B, hypotenuse, 1/2 B, one of the legs. So we can guess that the measure of the other leg will be square root of 3 over 2 B. If we have this configuration, then we have a 30-60-90 triangle, right? So knowing that angle BDA is 30 degrees, we can assume that angle ADC is also 30 degrees. So the angle BDC will be equal to 60 degrees. And since we have the same measure for line BD and DC, we can also assume that the angle BBC is 60 degrees as well as for angle BCD. Okay, this is just one of the explanations for validating this technique. I'm sure there are other explanations out there, but this is the easiest for us to grasp the validity of the technique. Okay, for the next part, inscribing a circle inside a triangle. Now, before we proceed, let us recall how to bisect an angle. So, we first strike an arc with the center on the vertex. The arc must intersect the two legs, the two rays of the angle. And then, we draw these two arcs. And then we form the angle bisector. So the idea for this is to draw a circle inside this given triangle such that the circle will intersect or just touch the sides of the triangle. Okay? So we have to be precise with finding out the location of the center of this circle. So what we have to do is first bisect angle A or bisect any angle of your choice and extend the angle bisector to the middle of the triangle. Next, bisect another angle, in this case angle B, and extend the angle bisector to the center of the triangle, making sure that they intersect at one point. Now, as you may have guessed, this intersection will be the center of our circle. Okay? What we have to do now is to make sure that the circle will properly touch the sides of the triangle. In order to do that, we have to draw a line passing through point O and perpendicular to one side of the triangle. So you only need to find one perpendicular line to one of the sides of the triangle. Okay, so we can do this procedure for drawing a perpendicular line passing through a point. So we have the vertical line intersecting AB at point H. Okay. Lastly, we can use O as the center and OH as the radius. Use our compass to draw the circle. Okay, that's the steps for drawing an inscribed circle in a triangle. And for some information, the center of the inscribed circle is called the incenter of the triangle. Now we go to the last technique for triangles, which is circumscribing a circle around a triangle. Now, the idea here, if previously we drew a circle inside the triangle, we will now draw a circle outside the triangle. Okay, so this one looks like a potato right now because of freehand, but you get the idea. Okay, now this is going to be easier because we have discussed how to draw a circle or an arc passing through 3 points. And as you can observe now, point A, B, and C are 3 points on this circle. That makes the sides of the triangle as the chords of the circle. Okay? So we just have to improvise our steps earlier and we will be successful in drawing that circle. So number one is draw a perpendicular bisector to side AB or any side of your choice. Then draw another perpendicular bisector. In this case, perpendicular bisector of A. It will intersect at some point. Now, it's just coincidence that it intersected at side AC as well, but it may intersect at any other locations. Okay. Now that we know the center of the uh, circle, we can just use our compass to complete the drawing. And as you may have guessed, the center of the circumscribed circle is the circumcenter of the triangle. Okay? So we have the incenter, that is the center of the inscribed circle, and we have the circumcenter, the center of the circumscribed circle. So those are the techniques for arcs and triangles. I hope you find the time to practice, and I hope you enjoy this part of ES1.